Today, one of the major physical constraints on computing platforms is power. You may be familiar with this fact if you've taken, say, a computer architecture class. Even so, let me give you my take on the basic problem here, perhaps by way of review for some of you. This is a well-known chart created in 2001 by Pat Gelsinger, then at Intel. The chart tracked power per unit area, or power density, across several generations of Intel's microprocessors. It tracked these up until about 2001, the time of the talk, and then extrapolated into the future. So what is power? Power measures the rate of energy burned or consumed per unit time. Power is usually measured in units of, say, joules per second or watts. Now, as it happens, the way people used to make sequential computers run faster up until the early aughts was to increase the clock rate. But as you'll see momentarily, when you do that, Gelsinger's prediction was that the amount of power per unit area would skyrocket, almost literally. And we know today how the story ended. Basically, in the early aughts, people stopped increasing the clock rate and went multi-core. Let's see why. Let's look more closely at the power consumed by a computer program. This chart comes from real data that one of my former graduate students collected. That student was Ji Choi, shown here doing what I gather is actual science. The chart shows measured power taken at a bunch of samples while the application is running. You can see that there's some fluctuation. Presumably, the power behavior of the application is changing as it's doing different things. A computing system at some point in time has two parts. I will call the first part constant power. Constant power is basically some baseline amount of power that the application or the computing system consumes independent of what it's doing. Now, you may have heard the terms static power and idle power being bandied about in your daily life. Because, who doesn't walk into a grocery store or yoga studio and hear people always talking about static power this or idle power that? Very roughly speaking, constant power is a general term that I'll use to encompass things like static and idle power. And if you don't know what I'm talking about, just remember constant power is baseline power. Now, suppose a computation runs. Depending on what parts of the system it's using, the power above and beyond constant power will fluctuate. Let's call those fluctuations dynamic power. Well, maybe not that dynamic. Now, real-life circuits can be much more complex than this simple model suggests. But let's not worry about that. Instead, let's take a cue from the famous statistician, George Box.